Before I go into kind of how we do ML at Splunk, I thought just by a brief way of introduction, I thought I'd talk about what brought me to Splunk, how I ended up here, and what I've done at Splunk as well. So I spent far too long studying maths in Nottingham after growing up in Newcastle. Clearly, I'm far too middle class to sound like a proper Geordie. And after finishing up at university, I was kind of a bit lost as to what I should actually do with my life. I knew I didn't want to stay in academia, but I didn't really know what types of jobs were out there. So I didn't put it up here, but I did a very brief stint as a recruitment consultant, purely because I was using this company to find a job. And they said to me one day, well, do you want to come here and work for us for a little while? And after 7.5 years surrounded by mathematicians, I thought, yeah, actually talking to people sounds like quite a nice thing to do. I'll go and do that. It was okay. It didn't provide any technical challenges, but what it did make me realize was that actually going out to different organizations, finding out what they do, finding out what's important to them, and finding out what challenges they have was something that really got me quite motivated. So I thought, hey, why don't I do this same kind of consultancy thing, but just from a technical angle? So that took me to Detica, who are now BAE Systems Applied Intelligence, kind of suggesting that the rest of BAE Systems does not apply intelligence, but let's ignore the poor name for now. Then on to Deloitte, and then I stumbled into Splunk. We were looking at Splunk as part of a client project. I came in for a meeting into the Splunk offices to figure out whether or not it was the right software for that particular customer. And I walked out with a business card and a strong suggestion that I should talk to them about a job, which I did. So I joined Splunk as a sales engineer, working in technical pre-sales, which I'm sure is something that you guys have heard a lot about during this week. And over the years, given I had a background in data science, a background in mathematics, I ended up moving on to a machine learning architect role, which is like a specialist pre-sales consultant. So effectively, when customers during the sales cycle or during adoption or during just general day-to-day use of Splunk ask us about, well, how do we apply ML? That would be when I'd come in to try and help them figure out what it is they can do and how they can do it. And more recently, I've ended up in the product organization, mostly, I think, because I was making a nuisance of myself, relaying all these complaints from customers back to the product org, making strong suggestions about what they should do. And my now boss effectively said, well, stop annoying me and just come and sort it out yourself, hey? So quite a varied journey at Splunk, but I think what that does mean is opportunity, right? 3 jobs in 3.5 years that I've been here. Lots of opportunity to try different things, to experience different jobs, and to work in different environments. So it's been a fun ride so far. On to ML at Splunk. I think when most people think about ML, they probably think about something like this: some hideously complicated maths. It's quite impenetrable for the most part. Generally, that's not what ML looks like. I mean, if you're I guess a classic data scientist, it will look something a bit more akin to this. So lots of Python code, potentially R, but not so much digging into the mathematics behind what's going on, more taking some commodity Python libraries, some commodity algorithms, and wrapping them in a way that works on the data that you have. So while that's the typical way of looking at things, at Splunk, we've taken a slightly different approach. So that kind of highly programmatic use, quite code level focus, we've tried to abstract away. So within our portfolio, and you might even have played around with it a bit this week, we have something called the Machine Learning Toolkit. And what that allows you to do is either train a model, so using an algorithm, or apply a model as part of a search pipeline. And I'll show you roughly what that looks like in a minute as well. But the idea here is we're trying to abstract away some of the complexity to make it as easy as possible for those who aren't data scientists, who certainly aren't mathematicians. I mean, if you care about the maths level, then yeah, you probably want to go and be a research scientist or something like that. Generally, that's not something that I see too often in industry. But we're trying to make it as easy as possible for those kind of non-data scientist type people to benefit from machine learning. And on top of that, as well as those kind of search level abstractions, which I'll show you in a moment, we have also provided a whole set of kind of pre-canned, pre-tuned assistance across our security products, across our IT ops products, that provide you with out-of-the-box content where you can apply ML, you can benefit from ML. And instead of it even being a search or something you have to codify yourself, it's more like you click through a few buttons, you look at a couple of dashboards, and it's a much easier user experience with a lot of those products. Okay, hopefully that makes sense. And I guess the main thing to note, Machine Learning Toolkit, it's one of the most downloaded apps on Splunkbase. So Splunkbase is our app store. You may well have looked at it over this week. The app store allows you to pull on a whole range of different types of apps. I think there's well over 2,000 these days, some developed by us at Splunk, some developed by our partner organizations, some developed by customers, some just developed by people who have an interest. But they allow you to, I guess, access things for free on top of your Splunk instance. The Machine Learning Toolkit is one example of that. Like I said, it's one of the most downloaded apps. It's actually our 4th most deployed Splunk built app, with the top one obviously being Splunk Enterprise, followed by Enterprise Cloud. So we're doing pretty well in terms of the number of customers that we touch, and also the number of analytics that we enable across our customer base. So rather than just kind of talking about what it is and what it looks like, I thought I'd actually show you how it can be used. So I've got a search here, and effectively all this search is doing is pulling back from Windows event logs, which if you've used a Windows machine in your life, most schools have them, given they aggressively target most industries, and schools are pretty easy. If you've used a Windows machine, every time you log on, every time you log off, and lots of other events, lots of things that you do on a Windows machine, that will get logged. And as such, it's one of the most common data types that we see at Splunk, because pretty much every industry uses Windows in some way, shape, or form. And therefore, pretty much every customer that we have has some Windows event logs. And they can be quite a rich source of information when you're trying to understand what users are doing across your system. Do we have accounts that are compromised? Do we have users that are compromised? Do we just see behavioral patterns that look unusual compared to what we'd expect across our environment? So I've got a search here that is basically looking for this event code. This is a logon failure. And it's not doing anything too complicated. It's just summing up, so counting the number of times it sees this event code across every 5-minute spans by that time span and by the host, so by the machine that that failed logon event occurred on. And you can see here we've got a bit of a time chart just showing us when those failed logon events have occurred. You can see there's maybe a bit of a cyclical pattern here, during working hours, during daytime. There's more failed logons than normal. And there's also some unusual points where we're seeing far more failed logons than others. So to me, I would look at a data set like this and I would say, okay, we have some clear outliers. And if I'm a security analyst, I would say, are those outliers benign? Could that be like a misconfiguration of an access policy somewhere that means users actually aren't able to log on as they normally would? Or is this indicative of something a bit more malicious? Could this be perhaps something called a brute force attack? So someone trying to break into an account by trying multiple different passwords, or something like a password spraying attack, which is someone kind of taking a single password and just trying it against multiple different user accounts to see if one of them happens to have that password. So there's lots of reasons why looking at failed logon events can be a useful source of information. But what we're trying to do here is trying to understand, well, actually, when are the points at which across this data we're seeing unusual spikes? And like I said, it's fairly easy to spot them visually, but for most of our customers, particularly when we're talking about petabytes of data a day, they don't necessarily have the time or the resources or the people to sit there and look at charts like this to manually spot those points when those peaks occur. So what we're going to do is we're going to use the machine learning toolkit to train a model that is able to say what the expected range of failed logons are in our data set. And what we have here, we're calling the fit command, which is something the machine learning toolkit provides you with. That command tells Splunk that it is going to use an algorithm with some input data to train a model. And the algorithm we're going to use is something called density function. Don't worry too much about what that is. Effectively, it's something that is able to train like a baseline against your data set for what the expected range of values are. So looking at numeric values. We're going to look at the count, so the number of failed logons that we've seen. If we spot an outlier, we're going to call it an outlier, and we're going to put that into a model called logon failures outlier detection model. So you can see I'm being very creative with my model naming. And it's as simple as running that search. So what this will do now is it will utilize the machine learning toolkit. It will take our data, it will push that into a Python process, which uses the density function algorithm, which is something that we at Splunk have actually created. There's multiple different ways of creating probability density functions, which is what we're doing. We have a bespoke application of that in the machine learning toolkit. And we now have a model that is able to flag our data as being an outlier or not. And what you can see here, we've got the kind of green line that is our count of failed logons. We also have this outlier count below, which we might be able to see a bit easier if we put it on its own axis, which I'll do now. So you can see for most of those peaks, particularly this period here, we are flagging those as outliers. There's a few points that we're not, probably because we're seeing so many outliers in this data set. But hey, looks like it's working, which is great. We're able to programmatically identify when those outliers are occurring. And if I wanted to run this into production, I could get rid of all of this fit command, replace it with an apply that effectively takes that model and runs it against new data. And I could then apply that model. We'll see exactly the same results come back, but I'm just trying to show you the process, what it looks like. We can apply that model. We'll be able to detect outliers. And if instead of running this search against all time, which is really bad practice, by the way, don't do that. You should, of course, run Splunk searches across much shorter time windows. But if we were to run that against data, every hour, every 15 minutes, as new data is coming into Splunk, we could then start to create alerts that would flag when that failed logon count is exceeding the expected range compared to what we've seen historically. So it can be a really useful way of generating some quite helpful alerts using machine learning, or even creating dashboards. We could keep this chart, we could put it up on a big screen somewhere and get managers to look at it when they wander around the room. So yeah, that's the machine learning toolkit at Splunk. This is currently how we provide ML to most of our customers. There are, of course, other things that we provide as well, particularly in premium applications, and some more code-heavy experiences as well. But for the most part, this is what ML looks like at Splunk. So any questions, anything that is worth going into in more detail, anything you guys would like to know? Happy to open the floor at this point.
Now's your chance to pick Greg's brain, because he looks after the toolkit, right? So he's the best person to answer any questions that you might have, even if it's things like, how do I get started with the data I've got? Tell me a little bit more about the wizards, anything like that. Feel free to sort of ask those questions now, either come off mute or pop them in the chat. If there are questions you don't want to ask in sort of a public forum, again, you can email them into the hackathon email address. But yeah, if there's any questions, feel free to shout out now. So one question that is there, Greg, is what advice do you have for the attendees looking to get into machine learning? So where's the best start point, I think?
Yeah, good question. So in all honesty, if you want to get into machine learning, if this is kind of something that you would see as an aspirational career path, you just need to find some projects that you can start working on where you can apply it. And often this can be the hardest thing to do, particularly when I think about what I've done since starting work longer ago than I'd care to admit. Being given the opportunity to work on a data science project, to work on a machine learning project, it doesn't always come along in the way that you expect it. So what I would suggest is, if you have a passion project or something that you find interesting, try and find something you can do, even if it's in the margins, that allows you to build up those skills. So an example of this, when I started at Splunk, like I said, I was a general sales engineer. But one of the things that I was working on or working with was universities. So we have lots of universities who are customers. They use Splunk predominantly for IT and security. But one thing that kept coming up in conversation was, can we actually use all of this data that we have about student interactions with our systems to predict how well they are likely to do during the exam period? Because we know what that interaction data looks like historically. We have exam results. We have, grades historically. So one of the things I started working on was actually, well, can we pull up kind of a test rig that takes those types of data sets and is able to make a prediction on student outcomes? And that wasn't something that was necessary to do my job, but it was something I found interesting, and it helped me build up quite a lot of skills with Splunk, because it wasn't something I was that familiar with prior to joining. So I think my advice would be kind of try and seek out the things that you're passionate about. and try and find ways of crowbarring that into your day-to-day job to build up those skills, even if it isn't something that you've been directly asked to do. Because ultimately the opportunities will come once you've got those skills and you can demonstrate them. See another question.
Yeah, so the other one is, why do you feel now is a good time to grow your career at Splunk?
Good question. Opportunity, again. So like I said, I've had 3 jobs since joining 3.5 years ago. I am not unique in that at all. We are a company that is going through a period of pretty rapid growth. And with growth comes potential to try new things, potential to get involved in things that maybe you wouldn't be able to if you were joining. Again, referring just to my own experience, back when I was at Deloitte, much bigger organization, much more process heavy, much harder to find the chances to go and try things that were maybe outside of your comfort zone or more of a passion than a job. So I think potential is the big reason that I would recommend anyone to join Splunk, along with the fact it's the most fun working environment that I think I've ever experienced. Everyone I've worked with at Splunk has been pretty awesome. I can't say that's the case with past employers. I think that's probably the safest way to put that. Yeah.
Cool. But then the last one for me, really, so a question is, everybody sees machine learning, so everybody talks about machine learning. Can you give some examples of what it's not?
What it's not? Gosh. Yeah. It might be easier to focus on what it's not.
You see a lot of people go, oh, ML, AI, that's the answer. That's what it'll do. It can do all of this. But we know that maybe that's not the case. Some of it might be some fluffy language.
It's definitely not AI. I'm a firm believer that there is no such thing as artificial intelligence yet. What it is good at pattern recognition. So if you have a discrete, describable problem that is well bounded, kind of like the one we looked at here, we're looking for a very specific thing, which is unusual spikes in failed logon events. That is something that machine learning can help with. If you're looking at something much more broad, such as, tell me about all the data that I have coming into my Splunk instance, that's not something that ML is likely to help you with. You need a sensible question to start with, a sensible hypothesis to start with. Otherwise, you're going to struggle to get much value from it. I mean, I guess I don't know how to answer this in the time we have, but there's other subtleties, I think, as well, particularly if we're going to focus purely on Splunk. ML at Splunk is not image recognition. It is not, voice to text. It is not anything like that. It is mostly numerical analysis to either find outliers, to make a prediction, to forecast a value, or to cluster some values into groups. They're kind of the main things that we can do at Splunk, given the type of data we have coming in.
Then the question that is there that I know is close to your heart: can MLTK predict the entire IT infrastructure anomalies for an organization, and how early opportunity does it give the organization to prepare for such an incident in advance?
You know, it's interesting that that should come up. I was literally just on a call. Today is the earliest I've started in a long time. I was just on a call with a customer who are trying to do exactly this. Can we predict things going wrong in our environment based on the data feeds, you know, all of the typical things that you would see from an IT stack, like memory utilization, load, API calls, error rates, all of that good stuff. Can we use that data to predict the health of our services and predict outages before they happen? The answer is yes, we can. We have customers who are doing it. We have customers who are doing it at scale. So for all of their IT services that they offer, they are using the machine learning toolkit to predict the relative level of service that service is likely to be operating at. So whether it's in a degraded state, whether it's completely down, or whether it's running as expected. The catch, as always, is how good is the data that you have coming in, and how much trust do you have in that data that's coming in? Because what we see with a lot of customers is they pull in some data, but not all data. They correlate things that aren't necessarily related. And they have big gaps in certain services. So for example, if you're running a web application, maybe you're only logging half of the activity that occurs through that web application. And if you're only logging half of the activity, how could you use that data to predict the health of that web application? And the answer is you can't. So the biggest challenge isn't so much, can we apply ML and can we use the machine learning toolkit specifically to predict outages across an entire environment? It's really, can you bring in enough data to build an accurate model of your environment before you even get to trying out some machine learning? Hopefully that makes sense as an answer. I'm just going to check back to the how early an opportunity does it give? So again, this is something that is fairly flexible, right? And maybe it's worth, there is actually a blog post on how we do this. Here we go. What we ship in our product is something that is able to predict, I think it's 30 minutes into the future. And I recognize that this is quite a lengthy search. Yeah. So 6 windows, each window is 5 minutes. So out of the box, we ship something that is able to predict 30 minutes into the future. There is no reason why you cannot change that window to be something longer, something shorter. You know, you have the control here within the search pipeline to decide how far out you want to make a prediction. 30 minutes is something that we, from a product perspective, have decided is reliable enough or generic enough that it should work with a wide range of customers. That's not to say you can't predict further out into the future. It's just the thing that we think, well, I guess the thing that we have rubber stamped as being a good target for most customers. And it may not sound much, 30 minutes may not sound much, but actually in the days of cloud computing, again, the customer I was talking to this morning, they said, even if we could get 5 minutes warning on an outage, we would be able to potentially do something about that. So there, I guess there's a few factors there. Yeah. Okay, thanks, cool.
Thanks, Greg. So the reason I said that was close to Greg's heart is before Greg moved, I think your promotion wasn't that based around looking at the prediction of the service health and everything in ITSI.
Yeah, it was. And I think that's why I kind of went onto a bit of a garbage in, garbage out rant, in that tends to be the problem. Most customers try and make predictions on things that they can't make predictions from.
That was brilliant, thank you. What I would say to everybody on the call is, obviously you've heard from Greg, he's pointed you to a few bits and pieces. You've got the toolkit on there, and you've got the wizards and everything else that we've talked about. So have a play, see what you can do. If you're having problems, just drop us an email. Use that hackathon@splunk.com email address. Thank you for joining. Thank you, Greg, for presenting. Very useful. And I'll drop this call now and open up the second call in case there's any questions.